Welcome to this explainer. Look, if you're managing workloads in the cloud, you already know that deep visibility is literally everything. Without it, you're just staring at logs at 3 a.m., crossing your fingers and hoping for a miracle. Today, we are on a mission to completely unpack the specific technical monitoring architectures for Google Kubernetes Engine and Compute Engine. And by the end of our time together, you're going to know exactly how to leverage these setups to achieve some seriously strict service-level objectives. But before we really get into the weeds, I want you to ask yourself a quick question. It's one thing to track the errors you actually expect, right? The ones you've explicitly written code to catch. But how is your infrastructure currently set up to catch those weird, anomalous behaviors that you totally don't see coming? To catch those true unknowns, you absolutely need a highly adaptable system. Well, that brings us to Google Cloud Observability. This is your flexible, zero-vendor lock-in foundation. Exactly what you need to build a truly robust monitoring strategy. It relies heavily on open source standards, which is huge because it means you can measure your systems consistently, no matter where your code actually ends up running. So here's our technical roadmap for today. We're going to start with the Cloud Monitoring Foundation, compare Google Managed Prometheus to the Ops Agent, look at centralizing our data with metric scopes, define those crucial service-level objectives, and finally wrap up with uptime checks and alerts. Okay, let's dive into this. Section 1, Cloud Monitoring Foundation. We're building this mental model from the bottom up. To really wrap our heads around cloud monitoring architecture, think of it basically like a 3-layer cake. Step 1 is your data collection layer. This is where you're out there actively gathering all your metrics, events, and metadata from your projects, your operating systems, and your custom code. Then we move to Step 2, the data storage layer. All that collected data flows right here, centrally managed by cloud monitoring. And from an implementation standpoint, this is a game changer because it totally abstracts away all the heavy lifting of maintaining scalable time series databases. Finally, in Step 3, we have the analysis and visualization layer. This is where your dashboards and automated alerts actually live, actively pulling from that massive, low-latency storage we just talked about. 1,500. Seriously, 1,500. That's the sheer volume of free system metrics automatically collected via black box platform monitoring right out of the box. Google Cloud automatically enables this by default, literally without any user effort at all. You just get deep visibility across more than 100 monitored resources immediately, and at zero cost. Moving on to Section 2, GMP versus Ops Agent. Let's talk about implementing that collection layer. Now, this is where we hit a real fork in the road for collection architectures. For Google Kubernetes Engine, you've got Google Managed Prometheus, or GMP. It leans heavily into a pull-based model using standard custom resource definitions. It's great because it seamlessly scrapes your metrics without making you babysit vulnerable Prometheus servers. But conversely, for applications running directly on Compute Engine virtual machines, the architecture shifts to the Ops Agent, which utilizes a push-based model. They're totally different paths for sure, but remember, they both feed directly into that unified cloud monitoring storage layer we just discussed. Let's zoom in on that Ops Agent implementation for a second. Architecturally speaking, it is a massive upgrade. Instead of dealing with that old legacy headache of running separate logging and monitoring agents, the Ops Agent is just a single unified binary. It pulls rich, fine-grained, in-process metrics right at the OS level for both Windows and Linux. You literally just deploy it, activate any of the 30-plus supported plugins for things like Nginx or Elasticsearch, and you're off. And best of all, it relies on OpenTelemetry standards using the OTLP protocol so you can easily instrument your own custom code. All right, Section 3, Centralizing with Metric Scopes. Time to bring all this data together. In a real-world enterprise setup, you've usually got a massive distributed microservices architecture spanning dozens of projects. So how do you see everything? Well, a metric scope is the mechanism that fixes this visibility problem. By utilizing strict IAM controls on a designated scoping project, you can securely attach and centralize your visibility. This gives your site reliability engineering teams a single, unified pane of glass across your entire massive GKE and Compute Engine footprint. And crucially, setting up this unified scope is the mandatory prerequisite for defining service-level objectives that span across all those different projects. And once you've scoped your projects, querying that scope becomes incredibly powerful. First off, cloud monitoring hands you opinionated default dashboards automatically. The very second it detects a VM or a GKE cluster, boom, the dashboards are just there. That dramatically reduces your discovery time during a frantic incident. When you need to dig deeper, you can use PromQL to perform complex, dynamic mathematical aggregations. You can even use PromQL to query standard system metrics from Compute Engine, not just Prometheus data.
And because we're built on open standards, you enjoy native Grafana integration simply by securely configuring cloud monitoring as your data source. Section 4. Defining service level objectives. This is where we actually engineer reliability. Okay, let's get into the concrete procedural steps to truly mature your monitoring strategy. Step 1, you have to transition away from blindly looking at raw metrics, like random CPU spikes. Just because CPU is high doesn't actually mean your users are suffering, right? Step 2, you define custom service level indicators, or SLIs, using those precise PromQL metrics, pulling directly from the centralized metric scope we just established. And finally, step 3, based on those SLIs, you establish your error budgets. This procedural shift is exactly what takes you from reactive fixing to proactive reliability engineering. The really crucial point here is how you track those error budgets. By utilizing precise PromQL metrics as your SLIs, cloud monitoring automatically and accurately tracks your error budgets over time. You monitor exact burn rates. Essentially, you're watching exactly how fast you are consuming your allowed margin of error. Because let's be honest, tracking your error budget burn rate is way better than tracking your SRE team's actual burnout rate. This approach allows you to calculate and react to real-world reliability mathematically rather than just guessing when things feel broken.
Section 5. Uptime checks and alerts. Let's talk about actionable notifications.
So this is all about configuring actionable notifications for when those carefully defined service level objectives are actually threatened. Step 1 is to configure global uptime checks. You want to aggressively probe your endpoints from outside your network to ensure your services are actually reachable to the rest of the world. In step 2, you tie that precise uptime data along with your burn rates directly into advanced alert policies to notify your on-call teams. And step 3 is the ultimate goal for everyone, reducing alert fatigue. By prioritizing real user journey degradation over just random background noise, your teams only wake up at 2 a.m. when it actually matters. We have covered a vast amount of ground today, from the foundational architectures of managed Prometheus and the Ops agent, all the way to defining specific indicators, tracking your burn rates, and scoping massive enterprise environments. So I want to leave you with this final thought. Is your current monitoring architecture fully equipped to leverage this kind of precise telemetry for both highly automated systems and rapid human-led incident resolution? Take a hard look at your own infrastructure's readiness today. Thank you so much for joining me on this explainer, and keep building those resilient systems.